Hi, in this second part we will continue talking about automating desktop UI testing in Rapise. I am Alexey Grinevich from Inflectra Rapise team. If you have any questions during or after this session, please use the chat window for this workshop. In this part of the workshop we will talk about using keyboard and mouse to interact with the application. And also we will consider some publicly available examples of such interactions. These are executable Rapise scripts that you may simply run from your desktop. Two most common ways of interacting with the application that we will consider in this part of the session are mouse and keyboard. Mouse is the most widespread and keyboard is less used, but it in many cases may be replacement for mouse. It may do mostly everything that mouse can do. And it's good to know about both of them to have workarounds for many useful cases. In one hand, mouse is the most universal way of input. I may access all parts of application using mouse cursor, and I may interact with it using mouse click. I may hit any button in the calculator, I may access menu, I may do operations, I may completely control it. The same is true for 99% of other Windows applications. For example, this is a Windows Explorer. I may go back and forth here using just mouse. I may use the navigation bar here, I may access the ribbon menu. Also, I may interact with this tree. The drawback of mouse is that some operations are not that explicit. I mean, for example, we need to expand the node in this files tree, and you see there is no expandable item here unless I hover mouse over the tree item. So it's sort of dynamic element that shows up when I hover on it. You may remember there is similar situation with YouTube videos. So YouTube shows you just the video fragment, and once you hover mouse it shows additional buttons. So you need to do interaction to see some control, and this control is only visible while mouse is over this element, because when I move mouse away it disappears. Also, some controls are really small. So this is a combo box style of control, and if I click in the center of it, it will navigate me to the desktop. But if I click on the right part of it, it will show me the drop down with list of available files. So while mouse is universal, the recording library should understand the meaning and behavior of these controls, like this arrow or this expand button, and should understand the logic behind them. So clicking here means expand the tree node, second click means collapse it, and this is the operation that we actually do when we click. We cannot rely on screen coordinates because the screens are usually fragile. Things like DPI settings or desktop scaling or even fonts installed to the system may affect how this is all represented. They may affect coordinates here, and even if we change the name of this folder like desktop or frameworks, anything that appears here after this folder gets shifted to the right if the name is longer, because this control becomes longer and this element also gets shifted. So it's always good to make sure that we have high level of recording if possible, so we don't rely on mouse coordinates, or we have some alternative methods, and we will talk about them more in this session. Keyboard input is another universal method of interaction with application. For example, here with calculator, regardless that there is no text input boxes, I may do everything using just keyboard. I may hit escape, and it's equivalent of pressing this clear button. I may type the number and it gets reflected in the input text field. I may press plus or asterisk or slash to make addition, multiplication or division correspondingly. So I may multiply by 2 and I may hit enter, which is equivalent of clicking on equals. The same is true for this Windows Explorer application. I may, for example, hit up and down and traverse across this tree. I may hit enter to enter the folder. I may hit backspace to go to upper folder. I may use tab to move to the tree item. So finally I should appear here in the tree view. Now I may press up and down to go up and down in the tree, and if I press right, it expands the tree item. If I press left, it collapses the item. So if I know the shortcuts, I may do many things with it. The benefit of this approach is that I'm not relying on screen layout or screen coordinates of elements. So if I know the order of folders, while staying here on the CRM folder, I want to go like on the Rapise framework examples folder. I know that I need to go like 4 folders down. So I just press down arrow 4 times and I'm here. I may now enter this folder and I may see its contents. Keyboard shortcuts is another powerful method. So while here in the application, the best way to find out what I can do is to press Alt key, and I have hints of what ribbon items I may access this way. For example, if I press H, I enter this Home tab and I see what operations do I have and how I may access them. For example, SI would do invert selection, and you see it inverted selection from nothing to everything. As for calculator that we are going to automate right now, it's good to know that keyboard is here, because usually the input to calculator is either number or operation, and number is a chunk of digits. 3 to 5 or 1, 2, 3, 4, 5. And if we type it using mouse, we have to find corresponding button for each digit and enter it. While usually this is not a convenient way because we need to do some programming. So if our goal of testing is to check the calculator functionality, internal algorithms that are doing these operations, then we don't much care about how we do this input. We need to enter it some way, get the result, and compare it to the expected result. If, in contrast, our goal is to test UI part of calculator, then we need to make sure that we are entering digits same way as user does it. In this case, we will need to press these buttons individually. But again, it all depends on the task, and in some cases you will need the first, in some cases you will need the latter way with keyboard, and it's good to know about both ways because they may be considered as workarounds for each other, helping to resolve some situations. So let's apply this knowledge to the task of testing this calculator program. I have new test created, it's empty yet, and I'm starting the recording. Here is our calculator. Select application to record window shows up. I'm choosing this calculator and press and select. So we're all set, we may do recording. I'm starting from very basic operation. So what I'm going to do, I'm going to clean this output, then do some very trivial mathematical operation. 1 plus 2, press equals to get the result, and I need to check this result. Luckily, as we discussed before, we have full access to the properties of this application, so we may simply read the value from this output field, and by using verify object properties, I may just make verification statement that would check that value equals to 3. And we are done. Press and finish. That's it. Appending it here. So we have basic operation recorded. It contains two parts. One is actually doing operation. I'm adding the hash sign to add a comment in RVL, and adding some explanation of what's going on here. Do math operation. And here I'm verifying the result of my operation. So in this case, expected result is 3. So this is very basic, very trivial test, and I may easily execute it, and I expect no doubts from it. It should just play and produce an expected result. Now, usually what I need is I want to make this test more complicated, more advanced. And for such kind of application, it makes sense to apply data-driven approach, because the input is very simple, but it allows many different kind of inputs that potentially touch many different types of functionality. Multiplication module, subtraction module, division module, and so on. They are a bit different. So I'm adding a couple more lines here, and I'm defining a map. From the beginning, I want this map to be quite short. It's just a demonstration, so it would be an inline map. So map type is rows, means inline map. Name of the map is calculator operations, calc ops. And then we will have first operand, then operation, then second operand, and then result. One tricky place here is result. We may see that it's formatted. So when I compare the result, either I have result in the plain format like 3, and then I would need to correct the output from the calculator to trim this trailing dot and white space. I could do this, but currently I want to do some shorter way, so I will apply the same formatting here as we have in our calculator output, so they should be the same. Now I'm entering a number of operations. For example, 4 minus 1 should be 3, 5 multiplied by 5 is 25 dot space. So I have input data ready. Now I need to figure out how to use it here, how to put it into my calculator. So as I discovered earlier, since my goal is not testing the buttons themselves, but to test the result of operation, I may use keyboard input. So I will add empty line before the equal sign, and here, and I don't want to use these button clicks. I completely remove these operations, selecting the rows and pressing del. And what I will use is the DoSendKeys operation that usually helps to deal with keyboard input. So I'm choosing the global object from the left side from the object tree, and I can find an operation DoSendKeys. I'm dragging it here, and the keys I'm going to send is actually the text of the operation. So I will send the value that's stored in the op1 of the calc-ops map. Calc-ops map and operation is op1. Then I will send the operation text. So in calculator, when you plus minus, you are actually doing the subtraction. That's good. So I'm just going to choose global here. I'm typing it using the keyboard. It's the fastest way. Do S, and it suggests me to put DoSendKeys, and it automatically puts me to the param value. So the key would be, I'm going back, calc-ops, and key is operation. Just operation. Finally, I'm putting the second operand. Again, just using the keyboard, it's the fastest way. So when you begin, you may start using mouse, but then it's really convenient to use RVL with keyboard because it allows you to do very fast input and fast scripting. Op2. So we enter first operand, we press the operation, we enter the second operand, and we click on the equals sign. And finally, we verify that result is equal to expected one. So I'm going to take the result from the same map, calc-ops, and from the column result. So verification would read the value from text, compare it to the expected result stored in this column. This is my test. I'm going to save it, just saved, and play it. It typed 4 minus 1 and checked that it's equal to 3. Now, it used just one row from this map. So to make this test truly data-driven, I need to select the piece of logic that I want to execute in a loop and add a loop for it. I'm choosing wrap selection into loop. Here I'm choosing the type of loop map and map name is calc operations, calc ops. That's it. So now it should perform both operations one by one. And it succeeded. So we used the keyboard input to solve the tricky problem and to bypass the need of pressing these calculator buttons, because pressing them would require some additional efforts. Well, sometimes you are required to use this method, so you cannot use keyboard. That happens. And for this case, we have something to see. Rapise is shipped with a number of built-in examples, and you may access them from the start page. The start page becomes visible when you choose View, Start Page. It's here, and on the right-hand side of the start page there is a number of examples, and two of them are of interest for us. First is RVL Calc KDT. I'm clicking on it and it gets opened. And you may see that we have similar type of test. So it has calc data map with operations and expected result. It's launching an application, and this is the topic we will consider later. Then it, in a loop, it calls the doPlaySheet RVL doPlaySheet command, and sheet name is press buttons, and it assigns a global variable op data to the first operation before calling these press buttons. This op data variable takes this value from the column op1. Then it does the same, but it's passing the value of operation and then the op2. The press buttons is a bit more tricky. You see it has a map between the digit and its object, where object is one of the objects learned from this calculator. You see, we learned all the digit buttons and all the operation buttons. So once we have a digit like 2, we find a button in the object tree, and the button here is remembered with this name, -2. We may just flash it to make sure it is the button we expect. So it's button number 2. Then in a loop, we use custom loop, which goes from 0 to number of characters in the op data string, or number of digits in the number we're going to type. We get each particular character, and then we find object ID by looking in the map for it. And then we find this object. So if we find the object by some custom name, we use operation global do wait for, and then we click on it. And we do it in a loop for each digit in given number or for each operation. So you see, it's a bit tricky approach, and you may find it hard, so it's not really trivial, but sometimes you have to do something like that. And my primary goal for now is to just make you aware that there are examples that you may just open in Rapise and execute, and you will see how it works. So if I start executing it, you see how it enters same numbers, but using just mouse. It's not as fast as keyboard input because it has some additional delays, but anyway, it's doing the same operations and fully controls the calculator. So execution done. You see, we also have screenshots enabled here, and we have report, and everything is passed. So our test is complete. And this is not the only way. We used RVL to enter the digits button by button, but sometimes such operations are easier when they are done in JavaScript. So for those who are aware about scripting and prefer to use it for such cases, there is another useful example that you may find appropriate. So there is another test called RVL Calc with JS. I'm opening it. The difference between this one and previous is that here we use a function to enter value. It's called enter number, and another function operation. These functions are defined in user.js file, and enter number is doing similar thing that we were doing in RVL. It's doing the same loop and typing of digits, but you see in JavaScript it looks much shorter. We don't need a map for this case. So it's another approach that you may use. So you have the calling RVL that is really similar to that of the previous example, but implementation is shorter and more concise. So depending on what is your preference, you may use either this approach or another approach. One note is that here we don't have dots and spaces at the end of result. And just for your information, if you wonder how to do the stream, it's done here, so you may find it useful. We have function check result, and function check result actually does the stream operation. It's doing some special trim, and special trim is implemented here. One thing that affects keyboard operation is keyboard input focus. Let's consider an example. Here we have new empty Rapise script, and we are going to interact with this application. It has two input fields. Both may accept keyboard input, and I may type something in each of them. I'm cleaning them, and I'm starting the recorder. It asks me to choose an application, since it's first recording. I'm going to click on this text field and type something. like AAA. It captures my input as set text. I'm doing finish and appending. I have a script with 2 rows. I'm going to change current contents of this input field and then play my script. Script is executed and it replaces the contents of this text field with the string AAA. There's one more method of making input. It's called DoSendKeys, and I'm going to switch to this method. DoSendKeys. Again, the same key combination, playing it. So it clicks on this field and then types. You may see that in this case, it didn't remove or replace the text. It simply did what we asked. It sent some keystrokes, and this way it appended the typed text here. So to deal with DoSendKeys, we need to first clean this field. Or, as alternative, if we know how Windows works, we may need to select the contents of this field. And now if we type something, it will first replace the selection, so remove it and just put whatever we typed in. Good idea, so let's use it. I'm reusing the same action, the same object, DoSendKeys, and my goal is to send Control and A combination. DoSendKeys allows that. I'm hitting F1 to see built-in help. It shows the topic about DoSendKeys, here it is, and it sends me to the article where I may read about particular key combinations. So I'm searching for the way how to press Control and something. So for Control, the special symbol is hat or circumflex accent, and then the symbol that should go with Control. So in this case it would be Control A. So I will type hat and A. This should select and then type my text. Playing it and see what will happen. So it selects and then types the text. Now, let me do something. Let me remove this do-click. So I will not be setting focus on this element explicitly. And I'm going to remove this focus from here. So I'm selecting some other control in the same application. Let me play this script. You see, instead of typing into this field, it typed in the field that contained the focus, despite of the fact that I said that I want to use this control, which is actually, if I flash it, is my text editor. It found this control because this object means find this object on the string. But then the DoSendKeys worked with other controls, because DoSendKeys use global keystrokes, and keystrokes goes to the element that currently contains the focus. So the moral of this story is, if you're doing with DoSendKeys, you should be aware about setting the focus. And there are two ways for that, either using do-click or using the tab key. So sometimes you just hit tab to go between different controls. In this case, it's not useful. So we may use click to put focus to this control. And in this case, even if we select another control, it would still, let me change the text, it would still use what we want. So in this part of this session, we talked about keyboard, mouse, publicly available examples, and input focus. Thanks for watching, and I hope to see you on the third part of this workshop.